Welcome to my poster. In recent years, we have been approaching the mesoscopic scale using fMRI. On this level, canonical models state that cortical input targets middle layers, while feedback targets superficial and deep layers. Independently, research lines in animal models have shown strong connectivity between finger representations in primary somatosensory cortex. We aimed to use the methodological advancements in ultra-high field fMRI in order to investigate the potential depth-dependent patterns underlying interdigit connectivity and translate the work from primates to humans. To do so, we acquired stimulation and resting state data using vascular space occupancy, or VASO, at 7T with an in-plane resolution of 0.75 mm squared. In VASO, cerebral blood volume and bold images are acquired in an interleaved fashion, so we end up having both contrasts. While bold data is more sensitive, blood volume measurements are more specific to the underlying microvasculature. In figure 2 of the poster, we show activation maps of a representative subject following stimulation. Importantly, we see nice and focal activations in central gray matter for VASO, and we were able to draw regions of interest for each subject and finger individually. Figure 3 then shows z-scores for each finger across cortical depth and across participants. We can clearly see peaks in middle layers for VASO illustrating its specificity and peaks in superficial layers for bold. In figure 4, we see an ROI we drew for a subject, here digit 3 in green. We use this as an example for now. In the resting state analysis, we use the mean time course for this finger ROI as a regressor in a GLM. For the resulting map, we extracted signal changes across cortical depth from the ROIs corresponding to the other two digits, here digit 2 and 4. We can see the profiles on the right. The signal changes can be interpreted similarly to correlations. The resulting profiles of all digit combinations were then demeaned and averaged across subjects. Coming back to the depth-dependent mechanisms, we repeated this process for seeds in superficial, middle, and deep layers independently. Coming to the final results in figure 5, we see that superficial layers show highest correlations with superficial layers, here in pink. Deep layers, in mint, show a U-shaped pattern of connectivity with other ROIs. We see increased connectivity with deep and superficial layers. Overall, middle layers show the weakest correlations and do not show clear patterns as the other two. To conclude, our results fit the canonical model discussed before with feed-forward input to middle layers and hypothetical feedback or lateral connectivity to superficial and deep layers. Thank you for your attention, and I'm happy to answer your questions during the poster session.